This video is going to demonstrate my integrated load meter, which integrates completely into PathPilot for any of the mills. It doesn't matter, as far as I know, which one you have. It also has a graphing utility, so you get a visual representation of what your spindle load has done per program. So if you have test.nc, it will show you the load for that entire program. You can also do it just by tool if you want to see what tool 125 did. I'm going to show you it in action. This is just a piece of steel that I'm going to cut pretty aggressively, at least for me. And what it's going to do, it's going to go down in a diagonal. So it's going to start with a light cut, and then it's just going to go deeper and deeper and deeper, and it's going to go down to just a 1/4 inch, but it'll show you how it works. So, and it's going to be loud, but here we go. And as you can see, the load slowly crept up and then backed off as soon as it hit G30. I'm gonna go open my garage door. This smoked up the garage. Now, that's only part of what this script does, or this hardware and script, what do you want to call it. I have a graphical display, a grapher built in, which you can get to by admin graph. And what it's going to do, it's going to ask a bunch of questions. Which file do you want? The standard file is load meter text. You have the option to hide inrush current spikes. When you first fire up the spindle, the wattage, the amperage goes through the roof and then comes back down and it settles. You have the option to hide that, to exclude it from the graph. I'm going to show everything for now. Do you want a custom y-axis in the graph? You'll see what that means in a second. I'll just let it auto scale for now. You can also graph RPM, which this stayed at 2500 the entire time, so not really necessary, but we'll do it. And here is where you can determine if you want to see just a certain NC program that's in the log, because the log's going to write everything like throughout the day until you rotate it or delete it, or a certain tool, but we'll do certain NC program. And here's everything on my log. I've got a top op for another program, some manual cutting, bottom ops for this same part that I make, spindle warm up, and then right here is the load meter hogger that we just ran. So click OK. And here's the graph. And as you can see, RPM is steady across the board. And then I forget if did I exclude the spike, but there's the spike, and then just slowly comes up, and then that's the G30, and it backs off. If we close that, run it again. Okay, so I forget if I hit it or not, but parse everything, auto scale, yes. Now we'll do a certain tool across the entire log. These are all the tools in the log file right now. I know that 113 earlier today showed some good load. Click that. And in that op, what I was doing is I was making a pocket across 4 work offsets. So this is the start of the pocket, and then it's already pre-drilled. So this was at the very bottom where the drill didn't go as far as the end mill, so there's a little bit of a load spike. And then that was in G54, G55, G56, G57. Actually, there's a better example that I can show you. Yes, yes, yes. If you want to hide inrush current, how many seconds do you want to exclude? About 5 seconds is good enough to let the motor settle down. And certain NC program, yes. So all top ops here for this program uses 3 or 4 tools. So what that looks like, and I don't know if you can see it in the video, looks like it uses 3 tools: white, gray, white, and then the tool number. And then you get a bunch of data down here. Peak wattage, peak RPM. What else can I show you? I got to turn it back on to show you this. So fire it up at 2500 RPM. Admin tail. We'll just show you, this is just showing you one line. This shows you history in real time. Okay. Can I show you? Boy, how do I do that without giving away some proprietary stuff? How about this? Jedit, home, operator, G code, Python, load meter, plugin. Perfect. This is the script that is the meter itself. There is all kinds of stuff that you can edit in here. I have it calibrated for my machine. I have I also have a UPS, a battery backup on this, a really expensive one that has a load monitor on the UPS itself, which is accurate. So as you saw it creep up during that hogging sequence, that matches closely with what's on my UPS, minus about 300 watts. I'm giving 300 watts to the steppers and the ECM, etc. So I have it pretty accurate for my machine, which, where is 230? I have it in here somewhere. Where is it? Oh, there it is. These are kind of some of the settings that you can adjust. So, because I have an 1100, my spindle voltage is 230, 770s. That should probably be 115. This 615 is, without getting too technical, what you should adjust to really dial in the wattages for your machine. What else can I show you? I think that's about it. It's very easy. I won't show it in the video. I'll take pictures of it. But all it does is it plugs into your computer via USB, and then you wrap a Hall monitor, a Hall effect sensor around one of your VFD wires that goes from the VFD up to the spindle. It takes less than 60 seconds. You do have to take the cover off of your VFD, find the wire that you need, clamp it around, and you're done. And then put the cover back on. And then, like I said, it just plugs in, and you copy files over into PathPilot like any other plug-in, but it's pretty easy. It's completely non-invasive. You're not cutting any wires or anything. And then you just copy files over, and those files don't affect PathPilot or edit any PathPilot files. So it's pretty lightweight and non-invasive for what it is. Thanks for watching. It'll be on my site. I probably will sell both the hardware and the software, or just the software only, because there's not much to it. It's just an Arduino and some code. But thanks for watching.